So for my project, I'm going to use calculus to see how fast you have to hit the tennis ball in order to get it over the net. And then to find the equation of how fast you have to hit it to get over the net, you have to use physics by knowing that the acceleration in the y direction is equal to negative gravity, and we know that the acceleration in the y direction is equal to the derivative of velocity with respect to t. So the velocity v of t is equal to negative g times t plus a constant. By solving, we know that the initial velocity is a constant. So v of t is equal to negative g times t plus plus initial velocity. So we know v of t is equal to the derivative of y with respect to t. So we get the final equation of y equals negative 1/2 g times t squared plus v sub 0 times t plus y sub 0. So now to get the equation in the x, we know that acceleration in the x direction is equal to 0. So, and also that acceleration is equal to the derivative of v with respect to t. So you know that v of t is equal to the initial velocity, and from that we can know that x of t is equal to the initial velocity times t plus the initial x. So over here we use this triangle to find out the initial velocity in the y direction and initial velocity in the x direction. So we plug that back into our equations, and we get y final is equal to negative 1/2 g times t squared plus the initial velocity times sine theta times t plus initial y, and x final is equal to the initial velocity times cosine theta times t plus the initial y. So here's the specific situation of the numbers of the court, like the dimensions. So you have to get it 39 feet and 3 feet high in order to get over in order to continue the point, or to just get over the net. So we use just 30 degrees, and gravity is 32 feet per second squared. So plugging the numbers into the equation, we get that time is equal to v sub 0 sine of 30 degrees divided by 16. And we plug time into the x of the x equation. So we plug that in for time, and we get that the initial velocity you have to hit the ball is 37.9614 feet per second, or approximately 27 miles per hour. That's it.